Okay, welcome back to the second part. We're on page 155 now. So we have Elizabeth wanting to know the angle at which the sun hits a tree in her backyard at 3 p.m. She finds that the length of the tree shadow is 24 feet at that time. At the same time of day, her shadow is 6 foot 5 inches. And we know that Elizabeth is 4 foot 8 inches tall. Find the height of the tree and hence the angle at which the sunlight hits the tree. I don't know why and hence. I think those are two different things, but okay. So pause for just a second and draw what you think this looks like. Label the diagram. This is different from any of that we've done so far. So if you have been in the habit of just drawing and going through the problem first and then checking your answer at the end with mine, you might not be able to do that this time. So pause and come back. Okay, so here's the ground. Hopefully yours is a little straighter than mine. Here is the tree that's in Elizabeth's backyard. Here is the sun. It's up here hitting the tree and everything around. And so we're going to say that this is the height of our tree, which we don't know. And then the sunlight is hitting the tree and it's causing it to cast a shadow, which is 24 feet long. Okay, and we are, that's not all the information we know. We also know that Elizabeth is outside at the same time to measure the 24 feet. We also know that she, I'm going to put her right here, she, well, let's give her some arms, is 4 foot 8 inches tall. So let's just say she is 4 foot 8 inches tall. And we know that her shadow right here is 6 foot 5 inches. And we are supposed to find two things. One is the height of the tree, and the other is this the angle at which the sun hits the tree. So if you remember from one of the previous problems that we did, problem 10, we know that if this is the angle at which the sun hits the tree, that we can also say that this right here, let me move this part so we don't get that confused with the angle. This angle right here is also the one that we're talking about, all right, which is in our triangle. So let's put the 6 foot 5 inches. We'll call this X for the angle, and then this is 6 foot 5 inches down here. Okay, hopefully that's clear. And then we're also trying to find Y, the height of the tree, right here. All right, so two variables, two different things we're trying to find. So hopefully you realize that we need to do two different problems to figure this out. So the first one that we're going to talk about is how to find the height of the tree. Now, if you remember, let me draw that in a little bit more clearly. If you remember back from a couple chapters ago, hopefully this should remind you of, I think, some sort of the generalization of the mid-segment theorem or the converse of the generalization of the mid-segment theorem or something. These two lines right here are parallel, right? And that means that the two triangles that are formed, this baby one and this big one, are similar, right? Which means that corresponding sides are proportional. So if I have this side right here, and this side right here, I'm comparing the vertical side in this triangle with the vertical side in this triangle is the same as the horizontal side in this triangle and the horizontal side in this triangle. We can do that in a number of ways. The way I have it set up in the answer key is I'm comparing this vertical side in the little one to the horizontal side in the little one. So 4 foot 8 inches over 6 foot 5 inches equals X over, no, sorry, not X, Y over 24 feet. All right, now clearly we've got some work to do here because this right here is a bit of a mess. So I'm going to change those into, the 4 foot is fine, the 6 foot is fine. It's just the inches part that are not fine. So instead of writing it like that, I'm going to write this as 4 feet and then 8 out of 12 inches. If we looked at it that way, that would give us a fractional amount out of a foot. 8 out of 12 is the same thing as 2/3. And then 6 and 5 inches, 6 foot 5 inches is the same as 6 and 5/12. Written that way, they're all in feet. And then that equals y over 24. All right. I would say that the easiest thing to do right here is to cross multiply. And so if we multiply this, we get 6 and 5/12. Y equals 24 times 4 and 2/3. All right. This is just a bit of a like a pre-algebra nightmare here for us to try and get all this done here. So I'm going to change this into improper fractions. For me, that'll be a little bit easier. 6 times 12 is 72 plus 5 is 77. So this is going to be 77/12 equals, 77/12 y equals, and then I'm going to change this into 14/3 times 24. Right, if we do that, the thirds here will cancel. We get 77/12 y equals 8 times 14 is 112. Multiply by the reciprocal, so we end up with y equals 112 times 12 over 77. And when we do that, we get y equals approximately 17.45 as our feet. Right, so the height of the tree is approximately 17.45 feet. Okay, we now have enough information to find x, because now we're just looking at this big triangle right here, and we see that we have this angle down here that's our reference angle. We know the opposite, we know the adjacent, and so we're going to do tangent. So we're going to say tangent of x equals opposite, which is 17.45 over 24. Okay, then we're going to use our calculator here, thank goodness. Honestly, you probably could have used your calculator over here too for it. So let's see, inverse tan of 17.45 divided by 24. And I get x equals 36 degrees. Again, we won't see many of these, but that is a trick that sometimes if two things are making a shadow, that it does form two similar triangles. I think you will see that, Grant and Evie, in trig next year. Definitely when you get to calc, you'll see those. Okay, next problem. Aliana is trying to determine the angle at which to aim her sprinkler nozzle to water the top of a 5-foot bush in her yard, assuming the water takes a straight path and the sprinkler is on the ground 4 feet from the tree. At what angle of inclination should she set it? Angle of inclination is another way of saying angle of elevation. So if you're looking at that and thinking you have no idea what that is, it's just the angle of elevation. Okay, pause for just a second and give me a diagram for this. This one's going to be a lot easier than the last one. Okay, so here we've got a little bush that she is trying to water. She's clearly not a gardener because she should not be watering the top of a bush. But the bush is 5 feet tall right here. And she wants to set her sprinkler 4 feet away from it. And she wants to water the top of it. Right. So what angle does she need to set it at? That would be what we're trying to find right there. All right. So again, stripping all that stuff away. Let me draw a little bit better. Stripping the bush out of the picture here, let's say we would end up with 5 and 4. and this is x. All right, so hopefully you see that that's tan of x equals opposite, which is 5, over adjacent, which is 4. All right, again, I've got plenty of room here, so I'm going to do what we did in class, just for those of you that have forgotten that. We're going to take tan inverse of both sides. Right, tan inverse of tangent. These undo each other, so we're just left with x. And then on the right, we've got tan inverse of 5 over 4. Again, I would have done that, but some of them I felt like I didn't have enough room. All right, so then we end up with x equals tan inverse of 5 over 4. And we get x equals 51.3 degrees. Okay, I'm going to pause and then do the last two.